Hello everyone. Welcome to the solution of LeetCode problem 232 named Implement Queue using stacks. In this problem, we have to implement a first in first out queue using only two stacks. The implemented queue should support all of the functions of a normal queue such that push, pop, peek, and empty. Here, the push method pushes element X into the back of the queue. The pop removes the element from the front of the queue and returns it. The peek returns the element at the front of the queue. And bool empty returns true if the queue is true, otherwise it will return false. Now, this is the simple problem statement. Now let's move on to the algorithm. Now here, we have to implement this for method, which is push, pop, peek, and empty. Now, before going to the implementation, let us try to understand the basic functionality of the queue and stack. Now, suppose it is queue. Queue operates in, first out manner. Suppose the element 1 enters into the queue, then if the element 2 enters into the queue, it will present here. And while removing, the element 1 will be removed from the queue first, then element 2 will be removed. Now queue will be something like the ticket counter. The person who arrives at the ticket counter first will get the ticket and remove the queue. But the stack is little bit different. Here, a stack operates in last in, first out manner, which is LIFO. That means, suppose the element 1 pushes into the stack, then if we push the element 2, then if we want to remove element from the stack, we have to remove the element which is come into the stack at last. So here, the last added element is 2, so we have to return or remove 2. So after that, we have to remove the element 1. So here we have seen that queue operates in, first out manner, but stack operates in last in, first out manner. Now in this problem, we have to implement a queue by using two of the stack. Suppose let's first take this first method, which is push. So here it will simply push one element into the queue. So here we can simply push element into the stack. Suppose we have pushed the element 1, then after we have pushed the element 2, and after we have pushed the element 3. So far so good, no problem at all. So here to implement the push method, we have to simply push the element into the first stack. Well, so far so good. Now we have to implement the pop method. Now it is little bit of tricky because in the queues pop, it will be the first in, first out. So here the element 1 appears at first. So we have to remove the element 1. But wait, the 1 rests as at the bottom of the stack 1. So we cannot remove the bottom element from the stack. That's why we have to take help of the second stack. Now, what if we put all of the element of the first stack into the second stack? So here, the first element will be 3. So 3 will be added here and 3 will be removed from the first stack. Now, the second element is 2. 2 is added into the stack 2 and removed into the first stack. Now, the element is 1, which is the stack 1. So if we add the stack 1 or the element 1 into the stack 2, so we have to remove the element 1 from stack 1. So here we have done is we have shifted all of the element of the stack 1 into the stack 2. Now, if we want to implement the pop method, we can simply remove the top element of the stack 2 because this element 1 appears into the stack at first. So here 1 is removed. Now, the pop mechanism is implemented by using the two of the stack. So here we have to implement the peak mechanism. So the peak is we have to return the top element of the stack or the front element of the queue, but we should not remove it. So here the algorithm is pretty similar for this pop mechanism. We have to shift all of the element of the stack 1 into the stack 2, and we have to return the top element of the stack 2, which is 1. Now, for the empty method, we have to check whether the stack 1 and stack 2 is empty or not. If both of them are empty, we have to simply return true. Otherwise, we have to simply return false. Now, as you notice that we have exchanged the stack 1 element into the stack 2, right? So these exchange operations basically performs in these two methods, which is pop and pick. So we can write a simple method such name that exchange, and we can reuse this common functionality. I hope you understood the algorithm. Now let's move on to the code. Now we have taken two stack, which is input and output. Input is the first stack, output is the second stack. Now, for the push method, we have to simply insert the element x into the input. And this is the exchange method. Here, we have added all of the input element into the output stack and make the input stack empty. Now, for this pop mechanism, we have to check whether the output stack is empty or not. If it is, that means we have to shift all of the input stack element into the output stack, and we have to remove the top element of the stack and we have to return it. For the peak, similarly, we have to check whether the output is empty or not. If our output is empty, so here we have to again shift all of the first stack value into the second stack, and we have to return the top element of the output stack. And for the empty method, we have to check whether both of the stack is empty or not. If both of the stack is empty, we have to return true. Otherwise, we have to return false. I hope you understood the code. Thank you everyone for watching this video. We will get back soon with another LeetCode solution.